others are drifting in, we can raise questions, comments, objections, things not directly related to the rest of the stuff. Or you can just relate to that.
How is he planning to use this, the idea of some discourse for fMRI?
I mean, you're asking how Vishak is going to do that. Okay, that's for Vishak to answer.
I need to find out what it is.
Okay. What he's trying to do is to see if there is a correlation between the modularity that comes from theoretical linguistics and the modularity in the brain. So one of the important parts of linguistic theory, we talked about rules or laws and representations. Another important component is the modular nature of the theory. So the laws function differently in different modules. We could say different components. So there is this sound component, there is a meaning component, there is a syntax component, and within syntax there are different modules. And they interact in different ways. And some of the modularity that linguists postulate are reflected in the functioning of the brain. So for example, there are certain kinds of specific language impairments. That language can be impaired, not the whole of language, but specific part of language can be impaired. So grammar can be impaired. That we knew long ago, Broca's area, and so on. But the communication will be kept, or the communication can be impaired, the grammar will be kept. But within that, there are very, very local rules. For example, you could lose your passive. What that means is, if you say something like, John saw Mary, the patient understands you. If you say, Mary was seen by John, then the patient understands that to mean that Mary is the person who saw. Mary is the person who sees. Okay, there is no passive rule. So whatever comes first, so if you say John was pinched by Mary, then John is the pincher, is the interpretation. And there are many things of that kind. This is with respect to language impairment. So where there is a head injury or some stroke, these things happen. There are also impairments where you can lose metaphor. Everything else is intact, but metaphorical interpretation goes. So if you say something like, Narendra Modi is the Obama of India, then they'll say, what the heck are you talking about? It doesn't make any sense. Because they're incapable of understanding metaphor, analogies and so on.
But would you be able to explain the whole thing, the whole idea of metaphor and all? Make them understand the joke and then ask them to use that joke?
Yeah, they might get that particular thing and say, haha, yes. I mean, it's like not understanding jokes. If you explain the joke, you get the humor. No. They might, and the next joke they will not understand. So they might, with some difficulty, understand this particular structure, but not the rest. In fact, it is very difficult for computers to understand analogies. So there is Douglas Hofstadter who has been studying this. He began with this computer program called Copycat, something like that. So what he was looking at was, how do you teach computers to recognize analogies? So here is an experiment. If you say something like, here is 3, 4, 5, 6, 4, 5, 4, 3, 2, 1, let us say, or let's remove 1. And another one, you say 21, 22, 23, 24, 5, 26, 25, 24, 53. Stop there. And suppose I were to ask you, what corresponds to 6 in this one? I think most people would look at this series and this series and say, what's your answer? Yeah? What corresponds to 6? 25, yeah. You know, what you're doing is you're seeing this as that, and this also is that, so you're picking the peak. Right? Suppose I were to say, okay, you're given this, and then you're given this one. 21, 20, 19, 18, 19, 20, 21. And here, 22. What corresponds to 6 in here? Yeah? 22. 22. Any other answer? Yeah, it could be here, right? Because when you say 22, you are taking the largest number. But if you say 18, you're saying this and this. What corresponds to this in this one is here. So you have two different analogies, right? And you can actually fix it in such a way that people can give 4 or 5 different analogies, all of which are equally good. So the brain is capable of doing that. And a great deal of creative thought actually comes from this. Computers are notoriously incapable of doing this. And his question was, how do you do this? And there are some brain correlates of this too. Some of these capabilities can disappear. Okay, now to take another example. So if you in English, you create a past tense phrase by attaching ed, stop, and you attach ed. This is the regular past tense. There is also the irregular past tense, like bring. You don't say bring, you say brought. Sleep, you don't say slept, you say slept. This happens to a handful of verbs which they need to be listed. Now, if you look at the data, it suggests that the past tense of this one and the past tense of this kind are done in 2 different modules, 2 different components of the grammar. I won't go into the details, but there is a lot of arguments to show that these 2 are 2 different kinds of rules. And when people did the fMRI studies to look at these 2, they discovered that these 2 are processed in different parts of the brain. Right? Number 1. Number 2, you could suffer some brain damage and lose one of them and not the other. Right? So here is a case where the theoretically motivated modularity corresponds to the anatomical modularity. Now, what Vishak is trying to do is to look at 2 different kinds of meaning. There's a kind of meaning that comes from the world. So if I ask you what is the meaning of the word green, you just have to randomly associate that noise to some object in the real world. Like this is green and this is not green kind of stuff. It is not part of language structure. But suppose I say something like, suppose I give you a word like brin. Okay, brin means pinch somebody's nose. Okay, and you can say John brinned Peter. Okay, you are just learning this new word. And suppose I say John re-brinned Peter. What would that mean? Did it again. And you know that because you know the meaning of this thing. That is built into the language structure, because there are only a finite number of things of this kind in any language. So there are certain aspects which are built into the language structure as opposed to the word. So if you say John brinned Peter, I told you what brinned means. But suppose I say John was brinned by Peter. Who is the guy who does the action? You know this, right? And that doesn't come from the relation between language and the world. It comes from the language structure itself, the passive structure. Passive has a certain meaning. So the kinds of meanings which are expressed in terms of the language structure versus kinds of meanings which are relation between language and the world, like this one. This I had to tell you, this is the relation between the word and the world. Whereas this is built into that, this is something that happened in the past. That is built into the structure. So what we do is we call it grammatical semantics. Grammatical means meaning that these are meanings built into the structure of the language. The other parts of the meaning are not. So the question then obviously would be, does it take place in a separate module of the, and some, I'm not sure, but I don't remember the details, but there is some suggestive data that the grammatical meanings can be affected by brain injury, while the other meanings will be kept, and vice versa, from brain injury. But it's not really conclusive, because the people who study brain impairments quite often don't understand the significance of what they are studying. And furthermore, that is not experimentally done. I mean, they don't know how to do the experiments on the brain impaired patients to answer some of these questions. So the question here is, when people judge the acceptability of sentences, and one of these rules are violated versus some of the rules of the world are violated, is there a difference in the location, the activity in the brain? Okay, so suppose I say, my toothbrush is pregnant. You laugh, say, that is ridiculous. There is nothing grammatically wrong with it. The reason why you laugh or you think this is an odd sentence is because you believe that toothbrushes are not the kinds of entities that can get pregnant. Suppose I said, I dreamt that my toothbrush was pregnant. That's okay, because in dreams all kinds of things can happen. So there are certain things that we expect to take place in this world that may not happen in dreams, and you know that this may not happen in some other planet. Okay, those are about our beliefs about this particular world. So if I said something like, John's father is pregnant again, we know that John's father, but the meaning of the word father is male, and males in this universe do not get pregnant. But if I said, my alien friend's father is pregnant, possibly because in that planet maybe both males and females get pregnant. How do we know? Right? Of course, you will then ask, what does it mean to say male? That's a different story. So violations of that kind are violations of our beliefs. Whereas if I tell you something like, John reshaped Bill's nose. John is a surgeon. John reshaped Bill's nose. But nobody had shaped Bill's nose earlier. And you'll ask, how can that be? Because reshape means you're doing it again. Somebody shaped it and you have to reshape it again. So if nobody shaped it earlier, right? Okay, the sentence is, John reshaped Bill's nose, but no one had shaped it earlier. Huh? God, okay. How about this? John reread the novel, but John reread the novel the first time in his life. That will be odd, right? To reread something you should have read it earlier. So that comes from this. So the question would be, will this sentence, or John reread the novel for the first time in his life, the oddity, is that happening the brain activity, is that happening in a different part of the brain? That's the question.
I have 3 doubts.
Hmm.
One is when you create pseudo words, like aren't pseudo words itself non-existent? So won't they be processed differently? Like
Not
brain.
not. There might be some more activity, that's all, but in the same place.
It will be the same.
It'll be roughly the same place. In fact, people do
What
this
makes it errors?
because people have done this experiment of creating nonsense words and doing testing. This people are doing like in the 60s. Okay, so here is an experiment. It's a purely behavioral experiment. People didn't look at the brain at that time.
Yeah, but if it's a pseudo word, won't it create other activations also which are not clearly related to that? It will recall memory and other things, right? And so won't it be additional noise?
Yeah, what you need to do is to make sure that it's not simply short-term memory. So you teach them a word. In this experiment, I taught this word immediately I did the experiment. Instead of that, you teach this word, come back the next day, and if it is the next day, it is no longer in the short-term memory, it is in the long-term memory. And you do this. And the memory experiments are typically done that way. You teach a new word, come back after a week and see what happens. So here's an experimental paradigm. There is a systematic relation between the vowels and things like meter, metric. This is E and this is A. Okay. Sane and sanity. This is A and this is A. Okay. Abound, abundance. And so on. These are, this is ow, this is ah. So E, A, and you can say I can give you lots of words, they are not coming to me, but let's say there is a kind of systematic vowel relation between them. The question is, this happens in English only for a few words. So what is there a rule that corresponds to this? Or is it that people simply memorize these patterns? So what people did in the 60s was teach people new words. So for example, if you teach a word like sabine, okay, and you teach the word sabine and whatever it is, and they learn the stuff, and then a week later, you give them this word. Do you say sabinity or do you say sabinity? Well, everybody said sabinity, not sabinity. So what that means is when they learn a new word, when they attach this ity, the rule automatically happens here. The I-E rule automatically happens to speakers, number one. So this happens like when you give them a gap of a week or so. This is to establish that the rule is real in the mind of the speakers. Another case was, suppose you teach them a word like sardine. Along with sardine, you also teach them sardinity. You don't change the vowel. Sardine, sardinity. Okay? And you come back after a week and you ask them to say this word. Even though they had learned it as sardinity, they would now say sardinity. They go against what they had actually learned because it fits a pattern. That means the pattern exists in their brain. These are kinds of evidence that suggest the existence of the rule or the law. So this, what I described to you just now, is purely behavioral. One of them is that of processing, and the other is one of storage. In the storage, they rearrange the word. This is memory. So a rule is real if it applies not only to production, but also to memory. And there are ways of proving these aspects of language structure.
take a word like bring, the cost of it, how do you decide it should be grinned or printed?
Oh, when you give a new word to speakers of English, they will typically use regular forms. Right? You don't extend that. However, there are ways of testing if they have the other pattern. So, for example, you teach them, for example, let's say, green, and you say the past tense is drank, right? Green, drank. That's easy to learn. But if you say the past tense is drink, drowned, after a week, if you ask them, they will say drank. Interestingly, children, when they learn to speak, they will say things like bring, brought, quite correctly, the first stage. And then at a later stage, you discover that they say bring, bringed, which is pretty, strange. But why should they, a child who can say bring, brought, then go to some incorrect use, bring, bringed? The next stage will be the children would start saying bring, brang. So what they're doing actually is first they are simply memorizing the stuff, bring, brang, and then the rule kicks in at a later stage. When the rule kicks in, the first rule that applies is the most general rule, namely e, a. Then the bring, brought is a much more specific rule, and that kicks in only much later.
So in the first stage of
First stage they simply memorize the stuff. Bring, past tense is brought. There is no rule. And then they learn a rule saying there is like e and a, and then they learn the second rule.
what kind of learning is this?
What kind of learning?
Yeah.
The natural learning, kids, without any instruction, kids start saying these things. Kids have all kinds of rules which do not exist in adult language. And quite often, if you try to correct them, they don't listen to you. So my daughter had this rule that every word must have 3 syllables. And so her name is Malavika, Tara, and Mohanan. So Malavika is 4 syllables, so she would say Manana, 3 syllables. Tara is 2 syllables, so she changed that to Tayaya. And my name, Mohanan, she would change to Monana. And this is because she also had a rule saying what is called consonant harmony. The consonant in the first syllable is repeated in the other syllables. She obviously didn't hear these rules in adult speech. She kept it for a long time. And the consonant harmony that I would say is like this. Take duck. One of the psycholinguist sons, I think Daniel, used to say duck because this sound is produced at the back of the mouth, and ga is the same place, so these two should be identical. And he had that rule that those 2 sounds must be from the same place. So Lisa Men, the mother psycholinguist, tells me that at some point, because she had heard her son saying guk, so she said, go bring that guk. And the son was surprised. Guk? Guk? He said, oh, duck. He would not allow his mother to say guk, but he would say guk. So it is not that he was incapable of saying duck, but he just had that rule. So some of these rules are, have no explanation in terms of adult language and so on. Children produce these rules spontaneously and stick to them. Of course, at a later point, they have to adapt to adult speech. So they are not, what I'm saying is they are not learned from the external environment. There is a kind of spontaneous rule generating device in their minds. And this is one of the central questions in language development theory, and it is called the logical problem of language acquisition. And the problem is like this. Even though children do not have very much intellectual maturity, ages 2 or 3, they can't even add 5 and 6. They master a very complex set of laws by the time they are 3. with very little evidence. And this is called the data is highly impoverished. How do they manage to do that? And the answer to the question is they don't learn these rules. The rules come from their being humans. Somehow or other it is part of their genetic inheritance. And they create these rules. Or they already know the rules and they're simply adjusting the rules here and there. That is the answer to this puzzle of logical problem of language acquisition. You're not convinced. Okay? And let me show you some cases which might convince you slightly better. So the point here is that there are rules or laws that you don't learn. Nobody teaches you, and you couldn't have picked it up from the data. So here's the rule of this kind. Suppose I say, John said Mary adores him. To me, John. You'll say that's okay. Right? It can mean that. It can also mean John said Mary adores him to mean some other person, like John said Mary adores him. That's also okay. But what if you said John said Mary adores her to mean Mary? Yeah, you see that's ridiculous. You can't do that, right? But if you said John said Mary adores herself, that's okay, right? So that meaning cannot be expressed in terms of her; it can be expressed by herself.
If I do not have a concept of herself, like I do not have that word in my vocabulary, say when
Yeah,
I'm a kid,
and during early
then-
stages of children's language acquisition, they will use her to mean both. This rule kicks in only about when they are about 10, 12 years old. Very young children don't have this rule. So
what rules do you mean are acquired like from birth, without any?
some of the abstract rules of this kind come in around the early teens, between 10 and 12 or 13, around that time. There is significant
By that
changes.
time, they would have heard a lot of these things.
You can show that this is not acquirable. No matter how much data you get, actual data, people have tried their best to get an inductive rule. Acquiring the rule from the data, it is impossible. It is impossible to get this rule. Okay, because what you have
Okay,
here,
could you state the rule again?
I haven't stated the rule. I'll state the rule of the idea. But try this one. Suppose you say himself. Why can't it refer to John? Right?
Mary a man.
Yeah, if Mary is a man, of course that will be okay,
Oh.
right? But if Mary is not a man, you cannot say it, right?
Yeah.
So the reason why this is bad is because there is a disagreement between them. But why can't it refer to John? And why can't it refer to somebody else? Okay. So this rule, why this is bad? Her referring to Mary, why is that bad? Let me state the rule as a pronoun cannot refer to the subject of the same verb. An object pronoun. An object pronoun cannot refer to the subject of the same verb. I'm kind of saying it not in a way that linguists would normally say it. I'm trying to say verb. This is not a good formulation of the law, but this will do for this purpose. And what that suggests is, if you say, John said Mary adores her brother, that's okay, even though it is the same her. Why? Reason is that this is the object, whereas here her is the sole object. Here the her is part of the object, not the object itself. So that's okay. And believe me, people have tried to get this inductively from huge bunches of data. There is no way. The only rule that you will acquire by data, large samples of data, will be okay, pronoun can refer to anything. Why is it that the pronoun cannot refer to Mary when it can refer to just about everybody else? The inductive generalization would say it can refer to anybody. It cannot block this. A similar case would be something like the learning of the source of honey in bees. During the early part of 20th century, people believed that learning takes place inductively. That is, you learn everything from the environment, and the idea was, during one learning theory that was popular was what is called behaviorism. And that said, the way you learn is you have stimulus and you have response. And you establish a connection between them through repetition. Okay, so for example, there's a dog and you ring a bell. Immediately after you ring the bell, you give the dog food. So the dog associates bell and the food. So this is, the stimulus is the bell and response is salivation. Okay. Now, if you do this a number of times, the dog will salivate even if you don't give any food, if you just ring the bell. This is called classical conditioning. Right? And there is what is called operant conditioning, which goes like this. There's a bird in the cage, and the bird accidentally presses a lever. Every time the bird presses a lever, there's a grain that is falling into the cage. And the bird figures out that if you press the lever, you get the grain. And when the bird is hungry, it presses the lever, goes and presses it. It becomes a regular habit in order to get the food. So these are the two forms of learning, the classical conditioning and the operant conditioning. Notice that between the stimulus and response, there is nothing like mind. That's the important part. Behaviorism doesn't accept the notion mind. And even today, I think in many psychology departments in India, behaviorism reigns supreme. So they will not use the word mind because it is supposed to be unscientific. They can't use words like consciousness, mind, free will. These are not part of this. They would say this is not science. Only behavior is science. Mind is not science because it is not observable.
Could you distinguish again between operant and classical?
Classical is simply that the animal doesn't do anything. Something is done to. Pavlov, for example, did this one, classical conditioning. Skinner, on the other hand, tried operant. Operant meaning that you do something and you receive a reward for your action. So the bird presses something and then you get the grain. Right? So these are the two forms of conditioning, associating stimuli with responses, the reward. Okay. Now, this was very popular in the early part of the 20th century. People subsequently discovered that it is not simply practice that does it. So in the behavior of bees, for example, bees can learn the source of honey in three different ways. One is the smell, the color, smell of the flower and honey. They will learn the source of honey on the basis of smell in 1 or 2 repetitions. That's all they need. You don't need a lot of repetition. But if it is color, then they need several repetitions. Okay. If it is the shape of the flower, they will need about, let's say, not just 10 or 20, but about 50. But they will finally learn the relation between the flower shape and the source of honey. But suppose you try direction. No matter how many times you repeat, the bees will never learn the connection. So in other words, that association is unteachable, unlearnable. Why should that be? Why is it that this is so easy and this is difficult and this is impossible? It is not that bees don't have any sense of direction. They do. They use direction in their dance. But you don't associate direction with honey. Bees are also sensitive to polarization. But you try to teach source of honey through polarization, they will not learn. More interestingly, if you teach bees the source of honey using both color and smell, okay, and then you delete smell, they will automatically delete color. If you delete color, smell is retained. So what that means is smell is dominant. There's a kind of hierarchy here, and if you delete the top one, the lower one goes, but if you delete the lower one, the top one doesn't go. This is not explainable in the behaviorist learning mode. The only way you can explain this is that bees are, by their genes, whatever, the connection between genes and behavior is very complex, but there is some genetic programming, whatever word you want to use, some connection that is pre-built, and that is what is happening. Whereas that probability, that tendency doesn't exist in the case of direction. So what is called, what in those days used to be called parallel distributed programming. This was like, I don't know, I think this was very fashionable in the 80s. Parallel distributed, what is called PDP. And the modern variant of that is neural network. Slightly different from the earlier version, but neural network also assumes that all learning is from environment. There is no biological component in the learning. But these are all cases where there is a combination of biology and experience together. They act in extremely interesting ways. And that's what is interesting about, not only about human learning, but also even about bee learning. If you cannot mimic a bee brain, what are the chances of you being able to mimic the human brain? The same kind of experiments have been done with rats. Saying there are certain things that they will not associate. Certain other things they will associate fairly quickly, easily, without any repetition. So what is interesting is really what they will not associate in spite of repetition. So this is one of them. Of course, there are some variations across languages. This rule that I wrote here is invariant across languages. So when we teach linguistics, we usually give this rule to students and say, if you can find a counterexample of this rule in any language, anywhere in the world, we'll buy your pizza. So far, nobody has been able to. And I'm pretty sure I can announce this in public. Nobody will be able to. Because we have done it so many times, so many linguists have tried. Not a single language in which this is violated. So why is it that this exists in every human language, no matter what the evolution of language, no matter what the cultural variation, this one doesn't change. Why is it persistent? The only explanation is that it has its roots in the genes. I'm not saying that there is a gene that encodes this particular rule. That is not, the relation is not between one gene and one. But of course, that same gene could be, doing various other things. But the pattern arises, emerges because of the gene interaction, and the pattern exists in the brain, and because of the brain, the rule emerges. So there are two levels of emergence, from genes to brain, and from brain to the language pattern.
So when you make up a word like brain and then you ask people to come up with a class, most of the time they'll add ed to
Yeah.
Can you change the structure of the word that you make up so that you can force them to use some other word?
You could do that deliberately, but after a while it will conform to the rules.
So there's no particular structure that forces the broad past tense association rather than the ed association.
Oh, wait, sorry, I misunderstood your first question. Okay, let's go back.
So-
Ask me the question again.
Let's say I come up with a word, you came up with bread.
Huh.
If I come up with some other word that
Okay.
inherently encodes a certain structure that
Which doesn't, for example, instead of bring, I did something like gring grot. Instead of gring grot, if I said what? If I said grouse grot. Grouse grot, you might teach it, but after some time it'll disappear and it'll go back to something else. They will either say grouse, groused, or make it.
Isn't grink and grink, will they go back to grank or will they keep it?
If you say gring and grot, some will make it grinked. Yeah. So what it means is that they will pick up some rule that is the closest.
So, but is there
It's
some
also more
structure inherent in the word that you make up?
There are some phonological cues, sound cues in the word. That's why I said there is a difference between grink and grot as opposed to grouse and grot. The unk or unk is important. That's what gives you the term.
One more doubt.
Mm.
It's on the degree of absurdity of a sentence or like word knowledge. Like first, the thing is like when I went there, the problem was like how do you get them to know that their English is good enough to say that something is wrong?
That you have to use these sentences if the things which are grammatically deviant
No, but then
are systematically
aren't you
just to be
choosing
wrong.
those people
Yeah.
that for what is that pre-conform to your behavioral task?
No, you're picking people who have a reasonable grammar in their head.
No, but there are others who do not have this rule. So,
Wait, hold on for a sec. Suppose every time you give the sentence, John thinks that Mary loves himself, and people judge that to be wrong. They obviously have the rule.
no,
The
let
behavior
us
indicates
take
that they have
something
the
like the her. John thinks that Mary loves.
John thinks that Mary loves her. Okay, and people
can
say
her
that her
refer
refers
to-
to Mary.
So,
If an adult says that,
uh,
then I would be very surprised.
no, like
Because that is not something that you learn. It is not a matter of English. Because this applies to Hindi, this applies to Malayalam, this applies to Chinese, every known language. So if an adult says yes, it can, then there is something wrong with the brain of the adult.
that is one possibility. Other
Yeah.
one is, as you said, like he doesn't know English that well.
No, you don't have to know. You just have to have some rudimentary. Unless you are picking up a 5-year-old child who hasn't heard any English, then they will not be able to say anything. They will not be able to have any system. The question is there a systematicity? Is there some systematicity in their rejection? And if the subjects systematically reject all the grammatically deviant sentences, then they have a grammar. It doesn't matter what their spelling is, it doesn't matter what their agreement rules are like. Those are not what we are interested in.
We actually checked out those kind of sentences which are in this context, but I do remember one or two. I should go back and
Yeah.
have a look at because
No, you cannot check out the sentences. You should check out the people who are giving you strange judgments. It is possible that they are not even paying attention. Then of course they'll say. So we noticed, for example, here that when you did this experiment here, people are reacting like in IIT exams.
yeah.
They were not, the sentences were not going through their minds. They saw the sentence and they started ticking exactly as in the case of exams. That's dangerous. So those things are problems in experiment design and unusual behavior of subjects who are used to a particular mode of functioning.
Let me rephrase the question in more concrete sense. How do you differentiate between a person who has such a rule and a person who does not have such a rule?
Okay. See, we have to distinguish between two kinds of rules. Some rules you don't learn from experience, it is as part of your biological inheritance. That's the case of the Mary loves her type. There is no environmental component at all. There's no cultural component. Another set of rules, there is some biological component and some environmental component. By and large, even if you have some bit of grammar, the rules exist in the brain. The rules may be slightly different, but the rules exist. Then there are rules like agreement. So for example, you say the boys are here versus the boys is here. Those things have very little of, I wouldn't say completely no, but very little of the biological component. Those are things that you learn. The rules of, for example, using the articles in English or spelling in English. So the kinds of things that school teachers teach their kids are the things that linguists are not interested in, because those are things that require teaching or learning from. The kinds of things that English language teachers are not aware of are the things that linguists are interested in. Let me show you some examples of sentences that will not appear in real life. Which pictures of each other did Mary say the boys like? This is not a sentence you'll ever have in an actual, newspaper clipping or actual conversation. See, the interpretation, you need this to do this each other. If you say something like John, the sentence is ungrammatical. Right? Because what this means is there were two boys, each boy liked the other boy's picture. Right? And which are those pictures? Now, if they say this is okay.
It can also mean Mary and John.
Yes, I guess it's possible. Yeah, that's a different kind of. What happens here is this one and this one together will give you this reading. Yeah, then you have to. If they say this is okay, if they say this is okay, you have to check what it means. You ask them what does it mean, and they'll give you this meaning. But if they accept this and reject this, that's a clear indication that the rule exists in the mind. And that is sufficient. It doesn't matter if they make mistakes in their articles, mistakes in their spelling, all kinds of things. In their vocabulary, it doesn't matter. These are abstract rules. And we are checking simply the existence of the abstract rules, which are not acquired from the experience.
So, now if I'm constructing an absurd sentence, should it be the least absurd or the most absurd thing that they will come across?
You absurd in the sense of grammar or absurd in the sense of
world knowledge?
World knowledge. Yeah, so there's a classic sentence that Chomsky constructed in the 50s. Colorless, green, ideas, sleep, furious. Just about every two word is self-contradictory. What does it mean to say colorless green, right? And what does it mean to say ideas, or what does it mean to say green ideas? What does it mean to say ideas sleep? And what is sleeping furiously? This is completely absurd in every case. Okay. Yeah, the only place where you can find this kind of sentence is in postmodern literature. Like postmodern literary critics write this kind of sentence, which nobody can understand. Other than that, I don't know. Possibly E. Cummings and so on, but poetry, writing. But people don't have any problems in understanding the grammar of this. It's perfectly grammatical. So there's a difference between the kinds of sentences that you actually see in real life and the grammaticality of sentence construction. So for example, you could say that building might have been being built when I was there. Okay, if you look at the actual data in the sense of, if you take all the newspaper articles and all the written text and look for this structure, people have done this. You don't find a single example. Why is this? Because it has this, what people call a modal, followed by this have and this en together, which is called perfective, and this be and this ing, and this be and this, which is passive, and this is progressive. This is the full expansion of the auxiliary system in English. The full expansion never occurs in real life, but people have no problems in accepting it. Yeah, that's a grammatical sentence. So people, the judgment is not based on whether it actually occurs or not. In contrast, if you change something, if you change the grammar, so for example, if you say that building has been being built, you can't have has there. Immediately people judge it to be ungrammatical. Or if you rearrange, if you say that building might been ungrammatical. So if you change the structure, even the least bit, the immediate response will be ungrammatical or unacceptable. Now, this sentence is actually pretty striking because there's a huge bunch of complications, fairly complex set of judgments in the auxiliary construction in relation to, for example, questions, tags, and so on. Very complex data. If I write down all the data, it'll take me about 2 or 3 pages. And in 1957, Chomsky wrote a couple of very simple rules that account for all this data. And most of us who got into linguistics did so because of those 2 rules. It was like, wow, it is so beautiful. How can you explain so much with just 2 simple rules? And when I looked at it, my immediate reaction was, this is what I want to do with my life. It was so beautiful that I spent a lot of time studying. I mean, the rest of my life was actually pursuing that dream of being able to do that kind of stuff. Of course, it took several years. So one of these days I'll show you how this is analyzed in, there are different ways of doing it, but roughly the same idea, that there is a relationship between this guy and this guy, between this guy and this guy and this guy, this guy and this guy and so on. That's where the trick lies. Once you see that relationship, the rule writing is simple. And then of course the linearity stuff, what follows what. There is a kind of discontinuous relationship. There is also a linear ordering. The 2 together is what gives you the grammar. And genes actually do that. Genes also have this discontinuous relationships across linear ordering relations. Okay, there were some questions which I got after the class, different kinds of questions. One of them had to do with the nature of what you observe and the laws that we construct. So let me begin with the concepts of trait and trait values and the notion of predictability. That's where laws come in. So, if you were to describe me, okay, you would say KPM. Okay. And then you say the trait, species, human. So that on the left hand side, I'm writing the the trait, the attribute, or the parameter. On the right hand side, I'm writing the value of that parameter or the value of that trait. So essentially following the attribute value system. Whether you call it trait or attribute or parameter or feature, doesn't matter. This is the value. And if you say height, say I'm 172 centimeters, that's the value. Weight, my weight is 90 kilograms. My age, let's say 62. About eyes, eyes, you will say, I use this symbol plus to mean I have eyes. That's one trait. There are also creatures which don't have eyes. I mean, species don't have eyes. And then another part of eyes, this number is 2. Not 3, not 4. Then I, you have to say color will be black. And so on and so on. Let's say you keep doing that. And you'll say something about lungs. Yes, lungs are present. How many? 2. Heart. Yes. How many? 1, not 2. Fingers. Yes. How many? 10. Blah, blah. So you will get a, what you have here is a very complex data point. The reason why I'm saying it's a point is because you're talking about just one entity in a large sample. But the data point exists in a multi-dimensional space. And these are the values, okay, of these different dimensions or these axes, if you wish. The question is, are these values predictable? Well, age, okay, let me try this. Age is 62, and you might say, if you just know that KPM belongs to the human species, how can you predict what the age is? Right? Not entirely right. You can predict certain things. For example, you can predict age is not more than 200. I'm just giving you a, right? If I were a redwood tree, of course, that could have been more than 200, but since I belong to the human species, it couldn't be that. So there is a range that you can still predict. Within that range, of course, there is some randomness. So the prediction here is that of what you might call constraint randomness. This, what I have written here, is a constraint. Within that constraint, within that range, you can't predict. Okay. Height, again, there is some variability, but you can still say if KPM's age is 62, it could be less than 2 feet, it could be more than 10 feet. Again, you're giving the constraint, but within that there is variability. You could also predict the most likely height, the mean, right, within that range. So what you get in this case is height and weight, so on. You get a curve like this and say, okay, this is the range and this is the most likely value. So it is not the case that it is completely unpredictable. There is considerable predictability in terms of the constraint and also the probability. You can make a probabilistic prediction. Applies to all these guys. Okay. Now you look at things like skin color. And skin color, suppose, let's change the story somewhat. Suppose you say very dark brown. Hair color is black. Okay, eye color, what is the prediction? Would that be green? Unlikely. So there is a constraint of that connects skin color, hair color, and eye color. Okay. Of course, if you just take one of them, and if you just say KPM is a human, the eye color could be green, blue, gray, brown, black, all of them. But when you add the other values, then suddenly there is a constraint coming up. These are the kinds of things that I mean by laws. Laws that apply to the trait values in a multidimensional space. So if I said something like Xena is some creature, some living organism. Okay, it could be a tree, it could be something. But let me tell you that Xena has a beak. Now, if I ask you how many legs does Xena have? 4 legs? 2. Okay, that again, there is a correlation between beakness and number of legs. Suppose I say Xena has 6 legs. And I ask you, does Xena have eyes? What kind of eyes? You'll say yes, Xena has compound eyes. Again, correlation between trait values. So you could begin by constructing laws of that kind. Systematic relations, predictable relations between trait values in a multidimensional space that constrains the possibilities and also gives you certain greater probabilities. And then you can ask the next question. These are simply observational laws. Because beak is something that you can observe, number of legs you can observe. Now you ask, why is it that there is this relation between legs and beak? If you ask that question, why does that correlation exist? Then you go into theory. You have to explain those correlations. So these are the 2 things that we do as linguists. We state these observational correlational laws. So such as, for example, you have, if you have some word like might, then it has to be followed by such and such form, which you can observe, and then you postulate abstract laws which are not observable, and they connect together a large number of observational laws. Sometimes, of course, even if you state the observational laws, if you state many observational laws, they connect together and start making new predictions, which is what I illustrated in the last class. The li and the suffixes li, ness, less, etc. There are predictions which come out of putting the laws together. Configuration of laws will give you new predictions. Okay, so that is the enterprise. When I say law, that's what I mean. Laws at the level of observable traits and trait values, and then explaining them in terms of unobservable traits and trait values that we invent. Like, for example, just as we invent things like gravity or magnetic repulsion and so on. So that was one of the questions that came up. Okay, the other question that came up was that of 2 kinds of meaning. I distinguish between meaning in terms of structurally encoded meaning and word knowledge. And I refer to what I call grammatical semantics, by which I meant the laws of meaning that are part of the laws of or the structure of language. This is the part that I'm interested in. But there is a different tradition of semantics. And I could call it, I don't know really what to call it, but quite often when people say formal semantics, formal semantics means use of formalisms like predicate calculus, lambda calculus, and so on. That's formal systems to say something about meaning. This is what is typically taught in linguistics courses when you say formal semantics. But this kind of semantics can also be formal. So that's not the basic point. Sometimes people refer to this as truth conditional semantics because they are investigating questions of truth. Let me explain what I mean by this. This is the logician's question about the relation between language and truth. So here is a case. All humans are mortal. APM is a human, and you can now deduce that APM is mortal. Classic stuff. Okay. So how can you deduce this? But not if you say something like KPM is mortal. You cannot deduce. Therefore, KPM is human. So this is bad logic. This is good logic. Now Aristotle knew this, and he simply stated this in terms of sentence rather than anything else. But at some point in the 19th century, these sentences and words were converted into some kind of algebra, into some kind of formal notation, which you're familiar with. So this word was written as this. Okay. So for all x, okay, then you write all humans are mortal. You use the symbol H, predicate H for human, and M for mortal. So you will now say, if H is human, then H is mortal. This is the first sentence. I've converted an English sentence into the predicate calculus notation. This one, KPM is human, will be human, and then you say KPM. This is a variable, this is a constant. From these two, there is a rule of logic, okay, called modus ponens, which sanctions the following inference, therefore mortal KPM. Now, the advantage of this is that computers can apply this logic. You don't have to know anything about the language. You have converted English words and English sentences into a formal notation. Okay? Simply a predicate calculus. I'm not using anything fancy, basic stuff that you teach kids in their undergraduate classes. And logicians were interested in this relations between sentences, premises, and the inferences. In order to do that, you have to convert words into concepts and sentences into propositions. And then what you're doing is, given proposition 1 and proposition 2, is proposition 3 a logical consequence? That's a question. That's a logician's question. And for that, you have to have this conversion. And these concepts and propositions are expressed in terms of some formalism. Like in mathematics, you don't have to know the meaning at all. Formal means you don't have to worry about the meaning. Meaning has been converted into formal symbols. So this is known, like for example, propositional calculus is called Boolean algebra. But that's only about 4 propositions. It doesn't unpack a proposition into predicate and its arguments. This goes beyond propositional calculus into predicate calculus. Now all this is fine. This is sort of familiar stuff, part of undergraduate courses. Now consider this. Suppose you say John murdered Bill in 1972. Suppose I ask you, is Bill alive now? You will tell me no, it couldn't be the case that Bill is alive. How did you make that inference? Okay. A logician philosopher, Richard Montague, asked this question and said, look, there's a problem for us. We don't know how to derive this inference. Predicate calculus will not do it because you are saying the conclusion is John is now dead. There is no formal relation between them. What is the connection between murder and being not alive? Okay. So Montague suggested the development of a certain kind of semantics called Montague. In those days it was called Montague semantics. The basic idea was that you unpack the meanings of words, not only the sentences but also the internal structure of words, into murder. If X murder Y is true, then here are the entailments. The following statements are also true. Okay. Y was alive prior to this. I just write it in some ordinary language. X acted on Y. The result of this action, okay, this is the way you write causation. X caused Y, or that action caused Y to change from alive, that is not dead, to dead. Okay, I'm giving you a very rough way of doing this, and these guys wrote it in formal symbols. I'm not using any of that stuff. If you unpack the meaning of X murdered Y into these entailments, this is the meaning of murder, then this would follow, right? Now a computer can compute without knowing the meaning by simply looking at the representation of murder. You can say, yes, of course, Y is dead. No, Y is not alive. So this is the essence of truth conditional semantics. They want to figure out under what conditions would a proposition expressed by a sentence be true. That enterprise is the logician's understanding of language. This is not the project that I was suggesting. I was suggesting the meaning embedded in language structure as opposed to meaning embedded in words of this kind. That's a separate enterprise. This is the relation between language and logic. This is the relation that we are trying to express in this kind of semantics. That may be valuable. In fact, I can see a reason for doing it, but that's a different pursuit. But quite often, if you read a book on formal semantics, a sophisticated version of this is what you're going to get. So formal semantics, the word formal semantics has come to be associated with this enterprise of converting words and sentences into concepts and atomic concepts of a word and the propositions with purpose. There are different ways of doing it. I won't go into the details. And me, I kind of, even though I agree that this is a valuable enterprise, I fall asleep when somebody is doing this. It doesn't interest me. In contrast to that, the truth conditional semantics is a slightly different kind of meaning that we call presupposition, which is part of this. And that goes like this. Let us say Z murdered, let us say, phi, some entity, versus Z killed phi. What's the difference between these? In both cases, what I described there, causing somebody to become not alive, is true for both. So in both cases, you will get the reading, the logic, the inference that phi is no longer alive. But there is a meaning difference. Okay? So for example, if phi is a human, then this is okay. But if fly is a cockroach, you wouldn't say you murdered a cockroach. You can say you killed a cockroach. mosquito, yes. You cannot say Zai murdered an enemy soldier. But it is a soldier of our own country, murder is okay. Some other country, no. Okay, especially if it's an enemy country. So murder has certain associations. Murder means not only that the person committed killing, but also the killing is illegal. And not only that, this is human. You don't murder chimpanzees. And then normally, there might be some people who say, he murdered my pet chimpanzee, but then you're attributing humanness to chimpanzees. That kind of meaning is what is presupposed rather than asserted. Why? Because if you say, did Z murder Phi? Notice that given that question, you cannot infer that Phi is now dead. You're asking for that information. But you still are implying that Phi is a human being, right? That Phi is a human being is still implied. So, for example, you couldn't say, did Z murder a mosquito? That is odd. That is odd because you have violated a presupposition that is hiding inside murder. So these are not matters of the word. These are matters, presuppositional meanings are built into words. These are structural meanings. Change murder into assassinate. And you say, Z assassinated a completely unknown orphan, some beggar somewhere. You can't. Why? Because assassinate presupposes that the person who is dead is somehow socio-politically prominent. You can assassinate kings, you can assassinate ministers, you can assassinate leaders, religious leaders, but you can't assassinate a completely unknown person, not a famous person. So that's a political act. That's also presupposition, because if you ask the question, did Z assassinate Phi, that meaning already comes. It is not a meaning that is asserted, but it's a meaning that is presupposed. There's a classic example.
Yeah, slightly after that question. When you have words like murder, kill, assassinate, does the society feel a need for these set of differences and then the words come? Or the words are there first and then the shapes are assigned to them?
Both happen. Sometimes words which are synonyms drift off into functional needs. Because there is words acquire meanings through certain socio-cultural significant spaces. So here is a nice example. In the Western culture, consider the distinction between an unkissed bride. That's okay. But what about a kissed bride? That's strange. The reason is because the act of kissing changes the status of the bride. But the kissed, so unkissed bride has a significant, it is a salient state of affairs. Okay, the bridegroom has refused to kiss the bride. Whereas kissed bride, that normally happens. It is not salient. All brides, once you get married, are kissed brides. So this doesn't make any sense. Now imagine a culture in which both are socially significant. Okay, there is a choice between unkissed brides and kissed brides. Some brides are kissed, but some brides are not kissed. So you have to, okay, she is an unkissed bride and this is a kissed bride. In that culture, this becomes possible. But this is not built into the language, this is built into the culture. The oddity comes from the culture, not from the language. Unlike the other one. And the way you distinguish between what is built into the language and what is part of the world is really by saying, okay, let's imagine the same thing happening in some other planet. Okay. If you change the world, then some oddities would disappear. but some other oddities would remain, and the things which remain, no matter where you change the world, those are the parts that are built into the language itself. No. Okay, let me give you one more example to see, to explain what I mean by that. Suppose you say, John called Mary a communist. And then she insulted him. Versus then she insulted him. Okay? John called Mary a communist, and then she insulted him. Has one meaning, and then she insulted him has another meaning. Now let me give you two scenarios. This happened in Soviet Russia when Stalin was alive. Which of these would you use? The first one. So what John was trying to do was to pay her a compliment, and she insults him. Okay? This will be very odd. Then she insulted him. There is no contrast. Okay. Insulted him, whereas she insulted him. This implies that John insulted Mary, and then Mary insulted John. Imagine that this is not in Soviet Russia, but in the United States during the communist witch hunt. Which one? This one. Because calling somebody a communist is an insult. John insulted Mary, and so Mary insulted John in return. Okay. Now, whether these sentences are grammatical or ungrammatical is a matter of the culture. It's a matter of whether you are part of Soviet Russia, communist Russia, or capitalist US. The meanings are, of course, embedded in this kind of linguistic form, the extra stress. But given that stress, whether it's an insult or not, this comes from the culture. That's the difference that I want to point out.
So my question is somewhat different. So here there are two different shades of meaning depending on the culture. It's the same word.
So, yeah, the language expresses certain meaning.
Yeah, it's possible that you might have two different words to indicate the two different.
Yeah. Yeah.
So, this is an example of that modularity and systematicity. So how does that happen? How does that originate? So,
okay.
So is it that this need is felt first and then somehow the words are discovered?
Right.
Or these words exist previously and then they start getting different meanings?
Both happen. Both happen. So take, for example, the number of words for the different stages of coconut. Coconut first is about this big yellow, and then it becomes this big, and then it becomes slightly bigger, and then there is some water inside it but no flesh, and there is a little bit of flesh but very tender, and so on and so on. Malayalam has about, I think, about 9 or 10 words. They are all distinct words. English has only one word, coconut. Why? Because for Englishmen, this is not significant. For Malayalis, all these things are very, very culturally significant items, so we have those words. So in this case, what has happened is the culture, like the snow, for example, snow case among Eskimos, they need different words for snow. So the words kind of come up. There are also cases where, take for example the English words red, orange, crimson, and many other words, scarlet, vermilion, blah, 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 many words. Malayalam has just one word ranging from orange to crimson. Okay. Now, it is not that Malayalis are not sensitive to the color differences. Okay. So if you show them an orange color and a red color, they will say, yeah, those are two different colors. They will remember it. They can perceive it. That's not the case. Or try, for example, stomachache. You just have one word. Now we have different kinds of stomachache, but we just have one word. So it's simply the words haven't caught up. So even though there is a tendency to fill these cultural needs using different words, I think of it as kind of certain valleys, and the words sort of fall into these valleys. but there are also values which are not filled. And in some cases what happens is when you have two words which are synonymous, then they drift into these two different values. But some languages tend to keep synonymy and not. Sanskrit, for example, seems to have lots of synonymy. English doesn't allow perfect synonymy. English must begin to distinguish somehow or other. If you have two near synonymous words, English finds a way of making them distinct after some time. And something like aid versus help is a classic example. They are near synonyms, but they have drifted apart slightly. So the process could be in both ways. The word exists and they find their values, or the values exist and you create those words.
Okay, so this drifting I can imagine. Creating words is a little more difficult to imagine.
FTP. We create new words when the culture changes. In 19th century, you didn't need a word like FTP. Now we have FTP as a noun and FTP as a verb. Right? Xerox. If you use the word I Xeroxed it, in 19th century people would say what? Okay.
No, but that came as a company name and then you
Yeah.
change the meaning and
Right.
so the word
But
existed
only
and
because
then
the
you
culture
came-
needed it.
Quiz, maybe?
Pardon me?
Origin of the word quiz.
Quiz. I have no idea where it came from. Yeah.
Some guy was told that you are to now create something like a new thing, which will be in the mouths of everybody in the whole city.
Oh, I see.
So overnight he painted on the walls quiz,
Huh.
and everybody started saying quiz, quiz, quiz. What is
Yeah.
quiz?
Yeah, that can happen. There are, yeah.
So I'm asking it in parallel with Darwin and Lamarck.
Huh. Oh, I see. Okay. Yeah, I see. Interestingly, the parts of language structure that I'm interested in, the abstract, deeper structures, do not go by Darwinian evolutionary principles. But when it comes to the surface aspects such as meanings of words, pronunciations, they obey the evolutionary expectations. So it is that what we need to explain is this contrast between those two aspects of language. So there are structural constraints of language which actually prevent communication. For example, there are meanings in Hindi that are expressible in Hindi fairly easily, which are not expressible in English because of structural constraints. To say those things in English, you take a paragraph, right? Why do those constraints exist? And these are kind of universal constraints. So that's where I think a lot of explanatory linguistics come in. They're curious about why those very strange constraints exist, especially when they prevent communication.
What happens in bilinguals?
Pardon me?
In bilinguals, they are structurally constrained.
Oh, actually, it is not even bilinguals in the same language. So Malayalam, for example, has two modes of relative clauses. By relative clause, I mean this. The boy who pinched my elephant is a pig. Some stuff like that. So this guy is a relative clause because it says the boy pinched the elephant. It modifies this guy. Okay. Now, you can also say the boy, or you can say the elephant. The elephant that the boy pinched is crying. So here, in this case, what happens is the object of pinch should be here, right? That object of pinch is here. So we call this a gap. Okay. In English, for example, if I ask a sentence like, "Who did Mary say Susan saw John pinched?" After pinch, we expect an object. That object is not there. So English uses that, what you call the gap relative construction. Hindi, on the other hand, uses what is called a correlative. You will say something like, Jo Hathi, please help me here. Jo Hathi, Jo, the Bache ne pinch kiya, wo Hathi, something like that, right? That's a correlative construction. There's no gap. You simply repeat the stuff. Malayalam has both because it has copied the correlative construction from Sanskrit, and this relative is from Dravidian. It is kind of used both. I think Konkani has the same Dravidian and Sanskrit, both relative clauses exist. The constraint on the gap relative, it functions exactly like English. Whereas the other guy, the correlative, there is no gap, and so there is no constraint, you can express those meanings. So it is in the same language, the same speaker, depending upon which structure you use, one structure blocks the meaning and the other structure doesn't block the meaning. But there is another structure for the other guy, the correlative construction, which I'm not going to explain. It's a fairly complicated path condition. So if there are two paths, they converge, they cannot now diverge. That's the rule, essentially. You have to express this in terms of some kind of graph theory concept. And that is not obeyed by this guy. That is obeyed by only the other guy, which is a kind of weird situation. Maybe after about 10 or 12 weeks, if I can manage it, I'll show you how this works. I'm just giving you a very rough picture of what the constraints are. Okay, so we're supposed to finish at 7. Sorry about going beyond.
So the actual timing is from 6 to 7 or 5:30 to 6:30?
5:30 to 6:30. Today people came late, so.
Okay, I'm getting mixed up with this class and the other class. So, okay, I should tell myself it is 5:30 to 6. Should we make it 6 to 7? I'm okay with it. 6 to 7? Okay, so I make an announcement. So that makes it easy for me because both begin at 7, so I will not get confused. Okay, and then the rule is, usually in any class I come half an hour advance and sit here, do whatever it is, and people want to ask questions. That's the time to chat about whatever it is that you want to chat about.